All right, ladies and gentlemen, we're going to be finding net force on a charge or on a given particle. For this problem, we're going to be finding the net force on Q1, or we'll call it particle 1 in this case. And essentially what you need to do in order to solve for this is you first need to find the electrical force between Q1 and Q2, and then you will also be finding the force between Q1 and Q3. All right, and once we find both of those forces, then we can go ahead and add them together. But you'll be using Coulomb's law, which remember is force is equal to K constant, or Boltzmann's constant, multiplied by Q1 times Q2 divided by the radius squared between them. So what that's going to look like in terms of net force is, if you think back to like when we did net force on for two-dimensional objects, we're just going to take and say my net force, and I'll call that net force on Q1 is equal to the force applied by Q2 plus the force applied by Q3. So like I said, essentially what we're doing is we're saying taking the force between these two plus the force between these two and adding them together to figure out what my overall net electrical force is going to be. Okay, so I'm going to erase some of this. So let's first figure out what is the force between Q1 and Q2. All right, so I'm just going to call it force of Q2. And what we're really saying there is it's the force of Q2 on Q1. All right, so how much force is that either attracting or repelling Q1? So we're going to say K constant, and I'm not actually going to write it out just for sake of space, but remember that K constant we said is 9 times 10 to the 9th. So K constant times Q1, which in this case, or your particle 1. So we're dealing with these two particles here. We're dealing with Q2 and Q1. So those are the two particles that I'm going to use. So I have a -8 microcoulombs, and I also have a +3 microcoulombs as well. One thing I want you to keep in mind is every time you're dealing with microcoulombs, that's what that mu represents, is micro. You're going to use the scientific notation of times 10 to the -6th. So in this case, we will have -8 times 10 to the -6th. And I guess, yeah, we'll just do it that way. Times 3 times 10 to the -6th. We're going to be dividing that by the radius between them squared. Now the radius between them, these two, is going to be 0.3 meters. And that's already in meters, and that's what we wanted in, so that's perfect. So 0.3 squared. If you want to pause the video and calculate that out, you can. You should end up getting an answer of about -2.39 newtons. Okay, so keep in mind that because this is a negative force, this is going to be an attractive force. All right, and that should make sense because we have a -8 charge over here, and we have a positive charge over here on Q2. Okay, so I'm just going to leave that number over there. So that is force of Q2. And then let's go and solve for force of Q3. So for force of Q3, I'm going to erase some of this stuff here. Now what we're going to be doing is we're going to be actually finding the charge between Q1 and Q3. So same process, use that K constant multiplied by my two charges. So you're still going to be using that -8 times 10 to the -6th, only now you're using Q3 instead of Q2. So it'll be -4 times 10 to the -6th. And then you will divide that all by the radius squared between them. And in this case, the radius squared between them is going to be that 0.3 plus 0.2. So we have 0.5 meters. And then we're going to square that. Taking a second to pause the video if you want to solve for that. And you should end up getting a positive 1.15 newtons. Okay, and since this is a positive value, that tells us that is an attractive, a repulsive force. We have a negative and a negative, so it's going to be a repulsive force. All right, so to find our final net force, because that's the whole idea here, is what we're trying to solve for. We want to solve for net force. So my net force, we said, is going to be that force of Q2 plus force of Q3. So what we'll end up getting is a negative 2.39 newtons plus a positive 1.15 newtons. So our final answer is going to end up being a negative 1.24 newtons. And so what that answer tells us, since we have a negative 1.24 newtons, we said that a negative force is going to be an attractive force. So between overall, this Q1 is going to be attracted to Q2 and Q3. So it's actually going to be moving in this direction, or it's going to be moving to the right. If you have any questions, make sure to send me an email. Have a great day.